Yeah.
I thought you were talking to everyone.
Nah. Star Wars Day. Yeah, so it's Star Wars Day. Yeah, no one dressed up for Star Wars Day, and I got to be honest, I'm perfectly okay with that. So.
Oh, because it's May 4th.
May the 4th be with you. Yeah, that's no. Who dressed up? Oh, look at there. Nice. We are adding and subtracting rational expressions. Don't you? Nah. Why do I put adding and subtraction? I'm sorry. Here, let me fix this. It's just one of these things. Adding, subtracting.
Oh, we just sent that in the song.
Which song? Mr. Roboto?
Is that the song?
I have no idea.
The song where he's all like, it's just one of those days. He said,
oh, that's Limp Bizkit.
Yeah.
I know that song. So I'll try to keep this this introduction brief. The first 3 or 4 minutes of this lecture are not dedicated necessarily to high school math. They're more dedicated to what we learned back in 4th grade, and me trying to sales pitch you that you understanding that really well will help you with what we're learning in Algebra 2. So the problem I've been using is something to this effect. 2/15 plus 3/10. And you might think that that is a 4th grade math problem, and yeah, you'd be right. But at its core, if I can get you to understand really the nature of what's going on, then I think it's going to help us with today. So here it goes. Someone taught you to find a least common denominator. I don't know who your 4th grade teacher was. Doesn't even matter. But someone taught you, and you just eventually developed instincts, and you know what it is. You know it's 30. And if I were to ask you why, you would say something like, well, because I can turn them both into 30, right? I could take the 15 times the 2, and I could take a 10 times the 3, and I could make both of the bottoms into something that's the same. 30.
He's put that like 3 times. You're doing it the wrong way.
I don't even know what he's talking about. I can't hear.
He's trying to do the multiplication way where you have 15 and 3.
Oh, you're trying to do crisscross applesauce?
Yeah.
Oh. I'm trying to. What I want you to see about this is that these denominators need to be factored. And at no point in your career has someone probably ever said you need to factor these numbers down. But I want you to see it so that as we get into the harder examples today, like numbers 3 through 11, then you understand why we're doing what we're doing. So the number 15 can be factored down. And instead of thinking of it as a 15, we ought to think of it as a 3 and a 5. Those are called prime factors. And how about the number 10? What can he be factored into? 2 and 5. Very good. I just literally couldn't hear you, bro. I didn't know what you're talking about. I couldn't hear you. So when we think about a common denominator, we have to think in terms of what pieces would I need? And here comes my dumb Lego analogy. I never know if it makes sense to anyone but me. But imagine you had, you were trying to like build things out of Legos, and think of the numbers as the Legos, and you want to put some numbers, little Lego numbers, in a bag. That's such a dumb analogy, but the point is you want to be able to hand the little baggie to somebody. Like, let's say I hand it to Lucas. I want him to be able to reach in there and pull out whatever he needs to construct 3 times 5. So he would need a piece that says 3, and he'd need a piece that says 5. So if I hand him a baggie that has 3 and 5 in it, he says, hey, thanks. And he puts the pieces back in, and then he hands it over to Parker. And then Parker says, hey, thanks. And then does Parker have enough pieces in the bag to build a 2 and a 5? He does not, because the bag I gave him only had a 3 and a 5. So what's missing? A 2, of course. And so when we think about the idea of a common denominator, we need to think in terms of what's the smallest possible collection of pieces that I could build that would make it possible for both people to do the job they need to do. So inside the bag, if I were to be as efficient as I possibly could, I would need to have 2, I would need to have a 3, and I would need to have only 1 5, because Luke only needs 1 to build his thing, and Parker only needs 1 to build his thing. And 2 times 3 times 5 is, of course, 30. Is that ringing any bells to you? At its core, that's what this is all about, is figuring out what you need to build denominators and then giving each fraction what it needs. What is the first fraction's bottom missing? That's this guy. What's his bottom missing? A 2. So we take what was on top, the 2, and we multiply it by 2, and we get 4. The second fraction, what was his bottom missing? So I take what was on the top, and I multiply it by what his bottom needs, make it 9. 4 plus 9 makes 13 out of 30. Because this fractional bottom right here, I'm circling it in green, in order to become the least common denominator, 2 times 3 times 5, it's missing a 3, isn't it? And so whatever you multiply to the bottom of a fraction, you have to multiply to the top, and 3 times 3 is 9. Got it? Okay. Just, I'm sorry if that seems a little maybe weird to talk about that, but that's really, again, going to be at the heart of everything here. So the first couple of examples are pretty basic. I'm going to number these for you. So if I stop numbering, because I'm not used to it, just call me on it, okay? So example number 1. (4x over 9 minus 7 over 3). This isn't one where we really need to get down to the nuts and bolts and start prying things apart. I mean, you're in high school, you know what's the least common denominator of 9 and 3. What'd you say? What's the least common denominator of 9 and 3? It's 9. 9 is the so small. 9 is the smallest number that 9 and 3 can both go into. 9 doesn't have to change to become 9, and 3 could be multiplied by 3 to make 9. So, wow, I didn't see that coming. You guys never cease to amaze me. So if we understand that the least common denominator is 9, then we have to go through each fraction now and ask ourselves, what do I have to do to change the bottom into what I need it to be? How do I have to change the first fraction? You don't. Very good. And how do we have to change the second fraction?
Multiply by 3.
Top and bottom both get multiplied by 3, which turns it into 21 over 9. And now that we have a common denominator, as you know, you can proceed to just add the tops together. So we're going to wind up with 4x minus 21 all over 9. Pretty unexciting answer there.
Did I get a pointer?
Oh, yeah. Sorry. Example number 2. I'm going to give you a little gift on this one. What do we see that we like? Fair enough. The denominators, perhaps? The bottoms are already the same, and that's really what matters now for you for the next week in this class. This is all about making the bottoms the same. And if someone's generous enough to throw one at you where the bottoms are already the same, then you're like, hey, like jackpot. So all I have to do is just add the tops together. And so I'm going to take negative 3x plus 9x. See how I did that? There's a minus and then a negative. What's negative 3x plus 9x?
Negative.
Coffee since you said that.
Negative positive 6.
Yeah. Nice. So I have 6x over 2x minus 4. Now, there's this thing in math, it's frustrating for students that, like, how do I know when I'm done? Well, you'll know when you're done when there's nothing that can be simplified. And who would actually look at this and think, well, I can simplify this? Well, I think what you're trying to say by just saying the number 2 is that we can factor the bottom, can't we? Okay, so I'm going to leave the top alone as 6 times x, and then I'm going to factor the bottom to be 2 times the quantity of x minus 2. And by doing that, what I've done now is I've turned the bottom, which is of course a subtraction problem, into a multiplication problem, which brings into play what we've been doing for the last week and a half. And that is, hey, now I can cancel stuff out. And so we realize now that that 6 that's on the top, since it's attached by times, and the 2 on the bottom, since it's attached by times, I can divide them both by 2, resulting in a 3 and a 1. And your final answer is 3x over x minus 2. Good so far? Nothing to it? All right. You won't see any more common denominators now. So from this point on, we're going to be responsible for switching them. So this one I think is pretty easy. I try to click through your assignment coming up to find like click like 50 times to see if I could see every possible outcome. Like what are these? What are they going to see? What are they going to see? And I think I got it covered. Fingers crossed. So your next example is this. And I'd never know if the Lego thing makes any sense. It's just maybe the way my weird brain works. But if I hand a little baggie of pieces to Brooke, she needs to look in there and be able to say, thank you for providing me with a 3 and an x. I can take them out and build my denominator. Then she takes them apart, puts them back in the baggie, and hands them over to Lexi. And Lexi says, I need to be able to look in the bag and see a 5 and an x. So if I'm going to cover both of their builds, what has to be in the bag? A 5 and an x? You need a 3 and an x to, geez Louise, what is, should I just go home? You need a, well, me too. You need a 3 and an x, and she needs a 5 and an x. What has to be in the bag to make sure that you're both happy?
A 5 and a 3.
That's what I'm talking about. I need a 3. I need a 5, I need an x, so the least common denominator is 15x. 15x covers both 3x and 5x. It contains them both, you could say. So having said that, what do I have to do to the first fraction to make the bottom what I want?
To make the top the 3x.
So what do I have to do to make it what I want?
Multiply by 5.
There you go. I'm going to multiply by 5 and multiply by 5. What do I have to do to the second fraction? Multiply by 3, multiply by 3. And I wind up with 30. Huh?
Because there's an x right there. Okay.
What's the, do you, oh no. Do you agree that the least common denominator is 15x?
Yes.
Okay. So do you agree that the bottom of this fraction as 3x only needs to be multiplied by 5 to turn it into this?
You need to put the x there.
Where?
Oh, never mind. And how did you get 38?
I did 50 minus 12.
Oh, you already, okay.
I just
you
jumped
already
ahead. I
did it.
shouldn't have done that. Things aren't going really well today. I probably should have known that that wasn't a good idea.
You're fine. I just got confused. I felt like, isn't that supposed to be 50?
All right. I'm a little scared because those ones were supposed to be really easy, and we're I haven't been numbering, I don't think. I apologize. This is officially and formally example number 4. And it goes like this. What happens now in the next like 10 minutes is officially potentially the hardest thing I have to explain to you all year. And some of you will get it like that, and some of you will not. And I don't know who's who. I just know that I'm sorry in advance. When it clicks, it's going to click. But anyone want to take a stab at what the least common denominator is?
Excellent.
Why would you say that? Why do we care? Stay the course.
X, you multiply the first one by x plus 3.
Golf clap for you, Parker. Okay, Parker's going to do just fine with this. Here's the deal. The denominator on the left is a single factor, and I need you to know that. One of the hardest things to overcome is for us to think that the bottom of this first fraction consists of an x and a minus 3. Trying to get you to overcome that is a mighty nasty task. I need you to understand that it is a thing called x minus 3. Now, Parker, excellent observation, spotted that x squared minus 9 can be factored. And if you haven't figured this out by now, wanting to know the factors of my denominators is pretty important, right? And so if I can take x squared minus 9 and say, hey, you're one of those things, I'm going to factor you down into x plus 3 times x minus 3. And now I can see that denominator from a correct perspective. And it just comes back again to the Lego pieces. It just comes back again to me asking you, if Lucas wants to build something with a piece, one piece called x minus 3, and then Dorian needs to build something with two pieces, an x minus 3 and an x plus 3. What must I put in the bag to make sure that everyone can do their jobs? I need one of each. I need a piece in there that says x plus 3, and I need a piece in there that says x minus 3. Therefore, the answer to the question, what do you need in the Ziploc, is always the least common denominator. If you can figure that out, you have found your common denominator. Good job, Parker. Now, having said that, I look at my two denominators and I simply say, first fraction, let's examine you first. What does his bottom need? So I'm going to multiply the bottom by x plus 3, and then in fairness, I'm also going to multiply the top by x plus 3. You give to the bottom what it needs, you give it to the top, just because fair's fair. It's what we do. You do it to the bottom, you do it to the top. What does the second fraction need? Nothing. It's already got both the pieces that it needs. So I simply have to modify the first fraction. Now, as I go through and do this, I've been doing this perhaps a little bit too fast today. I need you to stop and focus on this blue multiplication problem with me, okay? It's the end of Algebra 2, so we should be able to book right through this. If I answer that yellow times that white in there, it is 3x squared. Then what? It's that boom, 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 right? Oh boy. So x times 3x is 3x squared. What's x times negative 4? Okay, what's 3 times 3x? And what's negative 4x plus 9x? 5x. And what's 3 times negative 4? Negative 12. Good. I know.
Oh,
Look at me, just tempting fate, skipping steps like a total fool, right? It would have been a minus 12 at the end, but there is, of course, the second fraction, which is like, yeah, I'm ready to rock and roll. Let's get this done. And he's a minus 5. And so I'm just going to go ahead and attach that minus 5 to the minus 12 and just say, let's get this done. The only way that this would not be a finished product would be if we could factor the top. And so you should feel this inclination to want to know, am I done? And a real quick way to check to see, I'll switch colors here. I'll write in like blue for a minute. If I take this polynomial over here and I just take it for a test drive, I'm curious. I want to know if I can make a factor that's going to cancel one of the factors on the bottom. But you figure out right away that this ain't happening. Even if it could be factored, is either of my factors either going to be x plus 3 or x minus 3? Because is there 3 times anything right here that makes 17? No. So even if we could factor it, quite frankly, we'd be wasting our time. So we look at it and say, here in the box, final answer, done. Factoring at this point now only serves a purpose for us if we can make progress by doing it. Don't just factor something for the heck of it. All right, example number 5. Oh, number 3 over x minus 2 minus 6x. What stands out right away? Totally, and that should be the first thing that catches on your radar. You look at that 6x and go, what are you doing? You're supposed to be a fraction. How do we fix something when it's not a fraction? Of course. And so I'm going to take the 6x real quick, modify it, and just stick it over 1. And at least now I have 2 fractions. This question is so hard until it's not. This isn't one of those times where you kind of get it. You either fully understand or you don't. I'm going to ask you a question. What is the least common denominator? It is x minus 2. This denominator consists of the number 1. This denominator consists of the factor x minus 2. X minus 2 is all you need. So I look at the two fractions, and if my LCD is just x minus 2, then I say, first fraction, what do you need? And he says, nothing, I'm good. Move on to the next guy. Second fraction, what does he need? He needs to be multiplied on the bottom and on the top by x minus 2. And now we do the math. So my fraction looks like this. And I know on top that I have 3 minus 6x squared plus 12x. You're well within your rights after maybe a short little thinking time to say, why does that say plus 12x? Well, if you haven't figured it out, what are we distributing? Don't say 6x. What's distributing into these parentheses? A negative 6x. Let me circle it for you. That is what's being distributed, which is why we have to switch to plus 12x at the end. Again, it's our responsibility to rule out things that might need to be done. And so I'm going to take a quick moment and take the top and write it in standard form, negative 6x squared plus 12x plus 3. Can I factor that?
Yeah.
In a very, very broad sense, yeah, sure, why not? I could pull out a negative 3. So let's pull out a negative 3, which results in negative 3 times 2x squared minus, what is that, 4x minus 1. How am I doing? Yep, crushing it. And then here comes another sort of a big brain question. Can I factor this? I have two answers. Number one, no. Number two, I don't care. And again, I'll tell you why. Here's my logic. If I set out, if I say, Angelita, you have 2 minutes to factor this polynomial, I know the first thing that she's going to do is she's going to build 2 shells that look like this. And then she's going to say one of them has to be a plus and one of them has to be a minus. And what do the numbers in the back have to multiply to make? Right here, a 1. Is there any way in God's green earth that I'm going to construct, even if I could factor the top, would either of the factors match an x minus 2? So again, even if it could be factored, I don't care because it's not going to give me something to cancel. So what's the point? I hope that makes sense. So your final answer, you could even leave it, I guess if you left it like this, I probably wouldn't lose sleep at night, but it would be nice if you took that top and wrote it standard form. So. Questions there? All right, we're on the back page of the note card. Number 6. 11. Say that like John Bon Jovi would. Yeah. Yeah. Thanks for that, Dorian. We're halfway there. Living on a prayer. Thanks for the backup there on that one, Lucas. This is example number 6, and our job, again, here, I'll tell you what those knuckleheads said earlier today. Of course, I'm recording this, and now they know I think they're knuckleheads, but whatever. I said, what's the common denominator? And they said x minus 12. And I just about crawled up in a little ball and I said, no, that's not how this works. I know Parker gets it. Anyone else want to take a shot? What is the least common denominator of these two fractions? This denominator is named x minus 3. This denominator is named x plus 4. If I'm going to make a little bag of pieces that would contain both of those, what would have to be in my little bag of pieces? I would need one of these and one of these. That is my least common denominator. That's 6. All right. It's so impossible to understand until the switch flips, and then you say, that's the easiest thing in the world. Until that time, you have my heart. I wish I could do more to explain that better to you. Anyhow, once I understand that I need the bottom of the left one times the bottom of the right one, then I simply go through and ask the same question over and over again like a broken record. What does the first fraction's bottom need? Yes, so I will multiply by x plus 4. What does the second fraction's bottom need? Yes, and it was here earlier in the day where I kind of got told off a little bit, not really told off, but a student very politely reminded me that I should be showing more work. It's around this point in the lesson where I decide I no longer need to keep showing that I'm multiplying on the bottom. I'm not saying it's the best example to set for young people, but I'm saying like from this point on, you might often see that I'm not showing it on the bottom. I'm just going to acknowledge what I would have done on the bottom and just stick it up on the top. I hope you're okay with that. So when all is said and done, I wind up with, well, this, I'm not going to say all is said and done. I'm not going to quite go all the way yet. I have 7x squared plus 28x plus 4x squared minus 12x. And what's it all over? Nice job. And if you turned in an answer like this, I wouldn't really be too mad, but I would take points off, of course, because there's work to be done, right? We simplify. What do we simplify it into?
Combine the 4x squared with the 7x squared and the 28x with the negative.
Right, so we get 11x squared, excuse me, plus 16x all divided by x minus 3 times x plus 4. There's really no need to check if we can factor anything here. That top is pretty much toast, right? You guys have any questions on that one? Does that look good? All right, on to number 7. Oop, need a new page. Oh, number 7. No, I just can't remember to number my examples because I never do. And I'm just trying hard to do something I said I would do earlier. So. What do we have to do? Couldn't agree more. And there's a really important step that we have to do before we can do what Brooke told us to do. I totally agree with her. I need my LCD, but what do I have to do before I can figure out what it is? You have to factor. You can't know what common factors or overlapping factors or any of that kind of stuff is until you see what the factors are. And so on the left, if it helps you, you'll notice I keep trying to set an example in doing this. If it's just a binomial boring linear factor, putting it in parentheses might help you to remember that it's a package deal. Now, how do we factor this right-hand bottom?
X plus 3 times x.
Very good. And then I can take out, kind of out with the old and in with the new, take out the old denominator, put in the new factored version 2.0, and then it's pretty simple, I hope, to answer the question, what is the common denominator?
And x plus 3.
You need one of each. Yes, you'll know you found your common denominator when it contains all of the pieces in the other, all the denominators put together, like not put together, but if individually it contains them all, you're golden. So my least common denominator is one of each. X plus 3 times x minus 6. What's the first fraction's bottom need?
X minus 6.
Yes, and so I'm going to take his top times x minus 6. Again, right around this point in the lesson where someone gave me the what for about you got to multiply on the bottom. I know that, I'm just not showing it. Lazy. Second fraction, what does his bottom need?
Nothing.
Nothing. It has everything it needs. It already contains the least common denominator. We leave it alone, right? And now it's time for us to multiply. Let's try to have this go a little bit smoother than it did 20 minutes ago. See this math problem in the blue box? We got this. It is 4x squared minus 21x minus 18 minus x. Oh, I got to use my line tool.
Where'd you get 24 from? Or the 21?
Because I did 3x minus 24x. Look at
Oh,
my blue
okay.
rainbows up there. You see them?
Okay, I forgot you.
Yeah, I just thought that if I did, I would have had to explain it anyways. I should have just skipped it. You're right. So it's 4x squared minus 22x minus 18 all over x plus 3 times x minus 6. I really don't mean to be a broken record, but what do we have to consider at this point? Are we done? Yeah, the answer to are we done is I don't know. That needs to be your answer. I don't know. And how I'm going to find out is I'm going to factor the top if possible and just see if maybe there's something happening up there. I don't know. So I'm going to take the top and I'm going to pull out a greatest common factor of 2. And that's going to leave it as 2x squared minus 11x minus 9. And then I'm going to ask myself, can I factor this? Let me underline it in yellow for you. Can you factor this? I don't know. Let's see. It would have to be a 2x and a 1x, and there'd have to be 1 plus and 1 minus, and the numbers would have to multiply to make 9 and add to make negative 11. And because there's 1 plus and 1 minus, I don't see this happening. If you can't factor this, right? So the upshot, the takeaway is then that this is the final answer. This next one is the one that I've always said, for me, if I was the student sitting in my own room, this would be the hardest one, oddly enough, for me to understand. So I hope you disagree. Who'd have thunk this kind of question could be so difficult, but here it comes. What is the least common denominator? Yeah, you are good. The answer I commonly get is x minus 4. And that answer comes from the perspective of a person who has yet to understand that I need to understand that the x and the 4 are not detachable. They're not little pieces that I can cherry pick apart. X minus 4 is an object. He is completely and totally unrelated to this x. Parker went ahead and did a little extra math, but good job there, Parker. The least common denominator would have to be x times x minus 4. It's easy to think, well, doesn't the x minus 4 cover the x? No, doesn't work that way. No cherry picking. Is that a little rough? That one's always kind of made me feel like I wish I had a better way to say it. What does the first fraction's bottom need? So I shall multiply him by x minus 4. What does the second fraction's bottom need? So I shall multiply him by x. And then everything from here on out is just a basic pre-algebra kind of basic skills test. Distribution, combining like terms, maybe some factoring at the end, who knows? So over here on the left side, I'm going to get 5x minus 20. What am I distributing into these parentheses? It's not an x. It's a negative x. Do you see that? That this negative and this x are both distributing in kind of collectively as a team. So what does 3x become? Negative 3x squared. What does plus 5 become? Minus 5x. Good. If you would feel more comfortable I bet you would. If I had not written my X on the outside over there, I bet it would have felt better if I'd put my X right there. Might be more visually appealing to you. We don't like that. We shouldn't. We got to simplify. What do we get? Over.
X squared minus 4.
If you want to do that, you could say it, but it has to be x squared minus 4x. I get this question a lot. Should I multiply things back out? And my answer is generally no. Like you work to factor it, why undo all your work? So if you've already factored something, I'd say, yeah, leave it alone. It's all good. It's that top, we got to monkey with it until we can come to the conclusion that it's dead weight, which at this point, we could factor the top by pulling out a negative. That's not going to do me any good. All right, on to number 9.
You can write your number again.
What's the least common denominator?
Negative.
What? You're going to have to do a little bit more than that. I know where your heart is and you're
Negative
saying
1?
something good, but I'm going to ask my question.
Negative X is that?
Yeah. I asked this question earlier, and when I said, what's the common denominator? They all said, oh, no, they didn't. Initially, they said x minus 7 times 7 minus x. But we remember, and it hit you right away. You were like, this is that thing where if I can monkey out a negative, then I can take the 7 minus x and I can flip it, right? So for a very small, like a super nominal fee, I can take this second fraction and I can take this 7 minus x. I can't really like wave my wand at it and make it happen. But what I can do, ready for it, is I can take the 7 minus x and I can write it as x minus 7. And again, what's the fee? What toll do I have to pay in order to be able to do it? I have to pull out a negative. And where's be a good place to put that negative?
In front of the X.
How about right there?
Because then you can turn it into a positive.
Jackpot. And so by just a little bit of ingenuity and creativity and you know what I mean? Bam, look at what we got. We got a denominator that's the same. Good to go. That's a cool little trick to have in your bag of tricks, because you can take a denominator like that and just do a quick manipulation, and there's very little work actually to be done. What could be a beast of a problem is actually then laughably simple. You wind up with 4x plus 6 over x minus 7. Done. Magical. 2 more. I'm gonna make it, Dorian. Okay, I got this, buddy. Oh, sure. This is number 10. I'm writing it down. You're welcome. Brooke answered this really quickly back on example number 5. What stands out immediately? Yeah, we're missing a fractionosity here. Like, so this 3x minus 1, I'm going to take it and scoot it up just a little bit and put it over 1. And now everyone's happy. There's all is right in the world. We have a fraction plus a fraction. What's the least common denominator? Nice. X minus 5. And so I go fraction by fraction and ask the same question. All week you're going to do this. What does the bottom need? X minus 5. So I then will take the top and multiply it by what its bottom needs. Second fraction, what does his bottom need? Nothing. Very good. Now we're going to do that thing that we do that we want to be really good at. And that is multiplying these two binomials, the yellow and the white binomial, together. And we get 3x squared minus 16 x's plus 7 over x minus 5.
Did you already put that too?
I did, because I did the -5 times the -1, which is 5, and then I just said, heck, let's just add the 2. Why not, right? Question would be again, and I'm always proud when if I say crap like I'm about to say and it makes sense to you, I'm proud and I feel like we're doing something collectively correct. Even if you could factor the top, why do you know it's going to be a fruitless pursuit? You can't get a 5 out of a 7. So even if the top could be factored into something like 3x minus 7 times x plus 1, who cares? I'm not going to make anything that can cancel with an x minus 5. So I just look at this and say, I'm done. Right?
You exactly that?
3, 7, 21. No. Nope. Do you guys know the test for factoring, by the way? I feel like I've shown it to you before. If you ever want to know if something can be factored, you have to take the number in front times the number in back. What's 3 times 7? 21. And just always ask yourself, are there numbers in existence? Are there whole numbers in existence or integers in existence that multiply to make 21 and add to make -16? Do they exist? No. The only candidates would be like -1 and -21. Those add to make -22, -3 and -7. Those add to make -10. If the numbers don't exist, then the polynomial is not factorable. Okay? Last question. And I'm not doing it backwards this time. Not that anyone from third hour is going to watch this video, but if they are, I'm doing it right this time, suckers. So here it goes. You guys are doing a great job of answering questions. If I recall, the last time I asked about 5 minutes ago, it was a good team effort. I first said, what do we have to do? Brooke, if I recall correctly, said we have to find a common denominator. And then I said, yeah, but what do we have to do in order to be able to find the common denominator? Factor. The factors are what we need. You cannot factor the right side denominator. The only thing you can do is maybe just remind yourself, put it in parentheses like that. Keep it packaged. But the left side can factor, I think, pretty simply for us into what times what. Yeah, I love that you can do that fast. That's how it ought to be. X minus 8 times x plus 5. And now I'm going to take out the old unfactored denominator, and in its place, I'm going to bring in the factored version 2.0. And then the question is simple. What is the least common denominator? What do I need?
Nothing in the first one and x plus 5 in the second one.
Right. So do you understand? You never really did answer my question. What is the least common denominator?
X minus 8.
X minus 8
And
times x plus 5. Right. We understand that I need one of each. And so you're ahead of me, I guess. You're too good at this. First fraction, what does he need?
Nothing.
Nothing. Second fraction, what does he need?
X plus 5.
Good. So I'm going to take and I'm going to multiply him by x plus 5. And the reason this example came into existence this morning is because I wanted to make sure you caught something here. Watch out. This is a little bit tough. It's easy to make a mistake here. This is 3x squared minus x squared plus 7x plus 10.
You have to distribute that.
We have to distribute the negative sign.
Oh.
And the reason I'm going, I think, maybe a little bit slower by my standards here is because I wanted you to see what's going to happen. We still have to do that thing that we've been doing. We still have to multiply binomial by binomial and do that thing. Multiply, 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 multiply. But lurking in front is this minus sign. And he says, I will apply myself to everybody that comes after me. I'm a minus and I will distribute myself to everything on the top of that fraction. And that includes all of the terms in parentheses. And so we wind up with 3x squared minus x squared, which is 2x squared, minus 7x, minus 10, all over x minus 8 times x plus 5. Now that I've taught you that awesome, dope new trick, which has probably come up before, we just don't remember maybe, can the top be factored? We can definitively now answer this question. What is 2 times -10? It's not 20. It's -20. Can you think of any 2 integer numbers, whole numbers, that could multiply to make -20 and add to make -7?
7 times 5 and 4.
You can get really close with a +2 and a -10, but do they add to make -7? Then it can't be factored. Upshot. Final answer. Got it? There's a lot of notes.
You said I didn't need to, I needed